Good morning, everyone. In our previous lesson, we have learned that the conditional statement has two parts, the if part and the then part. The if part is what we call the hypothesis, and the then part of the statement is the conclusion. In short, we can say that if P, then Q, or in symbol, P with an arrow pointing to Q, which is read as P implies Q. In this lesson, we are going to learn how to form the converse, the inverse, and the contrapositive of a conditional statement. But before we proceed, let us first some review on what we have learned last lesson. Determine the hypothesis, as you see in learning task number 1. Label it P, and the conclusion, label it Q in the following conditional statement. Okay, let's do the first example. If the triangle is equilateral, then it is equiangular. This is the if part of the statement. So this is the hypothesis. We will label this as P. This is the then part of the statement. This is the conclusion, so we will label this as Q. Take note that in a conditional statement or in an if-then statement, sometimes the then word is not appearing. So I want you to do in your mind, determine which is the hypothesis, which is the conclusion of the following examples. Label it with P and Q. Okay? Then after that, we are going to discuss what is converse, what is inverse, what is contrapositive, and what is a biconditional statement. What is a converse statement? If you interchange the hypothesis and the conclusion of a conditional statement, then you form the converse statement. Therefore, kanina, if we have a conditional statement, if P, then Q, this time we have a converse of that. If Q, then P. Or in symbol, Q implies P. After doing the converse of a conditional statement, if the conditional statement is true, then its converse is also true. When both the conditional and converse statements are true, then we can connect the statements with the phrase if and only if. Kapag pareho raw true, we can form the biconditional statement by placing the phrase if and only if doon sa dalawang statement. Or in symbol, this is the symbol for a biconditional statement. Let's have an example. If for every input x, there is only one output function of x, then the relation is a function. Okay, let us analyze that example. The hypothesis of this statement is this one. If for every input x, there is only one output fx, And the conclusion is, then the relation is a function. Let's form the converse of this statement by interchanging the hypothesis and the conclusion. So kanina, if P, then Q. This time, the converse, if Q, then P. So, the relation is a function. This is your Q. If and only if, for every input X, there is only one output function of X. So this time, this becomes your Q. To form the converse, if Q, or this time, this becomes your P, the hypothesis. So you form the converse of the statement, if Q, then P. Now, I want you to do in your mind to determine if the converse of each statement in the learning task 1, if they form a biconditional statement. Remember that not all converse of a true conditional statement are also true. So, what about the inverse statement? What is an inverse statement? An inverse statement can be formed by negating the hypothesis and the conclusion of the conditional statement. If not P, then not Q. So if we are going to negate the hypothesis and the conclusion of a conditional statement, then we are forming the inverse statement. What about a contrapositive statement? Just the same as the inverse, if we are going to negate the converse statement, then we are forming the contrapositive of that statement. In short, if not P, then not Q. Now, let's go back to our first example. If a triangle is equilateral, then it is equiangular. We said that in a conditional statement, P, if P, then Q. So P, if a triangle is equilateral, Q, then it is equiangular. If we form the converse, we will interchange the hypothesis and the conclusion. So it will become if Q, then P. So we may rearrange this example as if it is equiangular, then it is, if the triangle is equiangular, then it is equilateral. What about the inverse? We said that the inverse is the negation of the conditional statement. So, kung yung ating conditional statement ay if P then Q, if we negate this one, if not P, then it is not Q. So, negative P, then negative Q. So, how do we do that? If the triangle is not equilateral, then it is not equiangular.